friends, welcome back to our channel. So in the previous session we have discussed about how to find the candidate keys and the super keys using the functional dependencies and the closures. So also we have seen a few examples in the previous session, and in this session also we'll see two more examples of finding the super keys and the candidate keys by using the functional dependencies and attribute closures, right? So let us take this relation first. So a relation with five attributes A, B, C, D and E, with following the functional dependencies. A, B tends to C, C tends to D and B tends to E. Now first let us find out the super key. So a super key is the closure of a set of attributes determines all the attributes of a relation, that we call it as a super key. Now the possibility A, B, C, D and E, the closure of this one is obviously A, B, C, D and E. So this is one super key. This is a super key because the closure of A, B, C, D, E, the set of this attribute closure can determine all the attributes. Now from the functional dependencies, if you know A, B, if you know the attributes A and B, we can determine the attribute C. So here we can simply eliminate this one. So A, B, D, E. Write down the closure for this one. So first the self attributes can be stored in the resultant set. So A, B, D and E. And if you know A and B, so this is a resultant set, and in this resultant set we are having A and B. So if you know A and B, we can get a C from the functional dependency 1. So we can also determine the C. So which is also all the five attributes, right? So this will also be the super key. Then from the second functional dependency, if you know C, we can remove D. We can determine D. So if you know C, we can determine D. But here we don't have the C, right? Coming to the next one, if you know B, we can determine E. So we can simply remove E. Now A, B, D. The closure of A, B, D will be, so first the self insertion A, comma B, comma D, and if you know A, B, we can get a C from the first dependency, and if you know C, we can get a D. So we have C in our resultant, right? So we can determine D. Sorry, T is already available. Okay, if you know C, we can available D is available. If you know B, we can get a D. E, we are having B, and we can determine E. So here also we can get all the five attributes for this particular closure. So this is also a super key. Now, is there any chance to reduce this super key? So according to the functional dependency, if you know A, B, we can get C. So there is no C here. If you know C, we can determine D. So here no C. If you know B, we can determine E. So here also there is no B. So this is the last one. But we can't say that A, B, D itself is a candidate key. So we have to find out all the combinations of this one. So we have to find out the combinations of A, B closure, similarly B, D closure, similarly A, D closure, and also A closure, B closure, D closure. So first let us assume that. So A, B closure. So A comma B will be the attributes which can determine with the help of AB attributes. And if you know AB, we can get a C. Yes, C. If you know C, we can get a D. Yes, we can get D. Now, if you know B, we can get E. Yes, we can get E. So you can observe AB closure can determine all the attributes, So this will also be the super key. This will also be the super key. Now BD plus, so BD closure of BD. So B, we can determine B and we can determine D. If you know B, we can determine E, and any other attributes we can determine? No. So this is, so only three attributes. We can't determine all the five. So this is not a super key. Coming to AD closure, so we can determine A and D by using AD plus, right? AD closure. So if you know A, nothing happens. If you know D, nothing happens. So this is the only closure, and this is also not a super key. And coming to the A plus, so A can be determined by using a And then if you know A, any other attribute? No. So this is the only attribute we can determine. So this is also not a super key. Coming to the B, if you know B, we can determine B. If you know B, we can determine E. If you know B and E, any other chances? No. So this is also not a super key. And D plus, if you know D, we can determine D. And if you know D, any other attribute? No, we can't determine any other attribute with only D. So this is also not a super key. So now the super keys for this relation are, so A, B, C, D, E, comma, A, B, D, E, comma, A, B, D, comma, A, B. Right? These are the super keys. So candidate key means we have studied that candidate key is nothing but a minimal set of super key. It's a minimal set of super key. So what is the minimal set of this super key? AB. AB. So candidate key is a minimal set of super key. Minimal set of super key. So AB is a candidate key. AB is a candidate key. So we can't tell that AB itself is only candidate key for this given relation. So from this, what we have to do? We have to find out the prime attributes. Prime attributes. So what are the prime attributes? So the attributes which are involved in the candidate key are the prime attributes. So here A comma B are the prime attributes. So what we have to do the next? So we have to check whether any one of the prime attribute is on RHS of any one of the functional dependency. So A and B, is there any functional dependency with RHS of A and B? No. So no, not in RHS of any functional dependency. Not in RHS of any functional dependency. So simply we can say AB is only candidate key. Candidate key. AB is only candidate key. Right? So first we need to find the closures, and after that we have to find out all the super keys. We have to identify all the super keys. From that we have to finalize the candidate key, and we can't say that that's the only candidate key. So from that particular candidate key we have to find out all the prime attributes and check whether any one of the prime attribute is on RHS of any one of the functional dependency. If so, just replace that one with the corresponding LHS and follow the same procedure and find out again the candidate key. Right? But here the prime attributes are A and B which are not in RHS of any functional dependency. RHS means this one. So this is the RHS. So in all the three functional dependencies, the RHS is not equal to either A or B. So obviously we can say AB is the only candidate key for the given relation A, B, C, D, E with given functional dependencies. Right? So hope you understood this one. So let us check one more problem on this one. So finding of super keys and candidate keys. So let us take one more example. So let us find out the super keys and the candidate key for this particular relation with the given functional dependencies. First let us find out the closure. So A, B, C, D, E, H. So this is a closure. So which can find the attributes A, comma B, comma C, D, E and H. So all the attributes. So obviously this will be the super key. Right? Next, from the functional dependencies, you can see if you know A, we can get the D. Okay, if you know A, we can get the D. So we can remove this. B, not a D. It's a B. Okay, if you know A, we can determine B. So A, C, D, E and H. Closure is A, C, D, E, H, and if you know A, we can get a B, so we can add B here. Right? So from the next functional dependency, if you know BC, we can get D, but here we are not having any B. Okay, go to the next one. If you know E, we can determine C. If you know E, we can determine C. You can remove this one. So A, D, E, H. Closure A, D, E, H. And if you know E, sorry, if you know A, we can get a B. If you know E, you can get C. So all the attributes have been done, right? So this is also a super key and this is also a super key. And for next functional dependency, if you know D, we can get A. If you know D, we can get A. So you can simply remove D, A. Okay. So D, E, and H. Closure D, comma E, comma H. And if you know D, we can get A. So we can get A. If you know A, we can get a B. So we can get a B. If you know E, we can get a C. So we can get a C. So this is also a super key. This is also a super key. So check whether still we can reduce the super key. So from the functional dependencies, we can't reduce this one. So write down all the combinations here. So we can't say this is the minimal super key among all these four. So this will be the candidate key. So because we have to find out all the following, all the possibilities, right? So DE closure. So DE, it can determine D, comma E. And if you know D, we can get A. And if you know E, we can get a C. And here, if you know A, we can get a B. Okay, if you know BC, we can get D. Okay, if you know BC, we can get D. Yes, D. So A, B, C, D, E, only this one. So, but it can't determine H. Okay, the H can't be determined here. So this is not a super key. Next, EH. EH. So we can determine E, comma H. From E, we can determine E, comma H. And if you know E, we can get a C. And if you know H, so no other combination, right? So only the 3. So this is also not a super key because this closure doesn't determine all the attributes. And here, next one, DH. Find out the closure of DH. So DH, we can determine D and H. If you know D, we can determine A. If you know A, we can determine B. And with the result answer, that means D, H, A, B. Any other attribute we can determine? No. Right. So this is also not a super key. Now individually, you have to find for the single closures. So D closure. So we can determine D, and with D we can determine A. With A we can determine B. That's it. There is no other combination. There is no other attribute we can determine by using D, A, B. So if you want to determine C, we need to get a E, right? There is no chance. So this is also not a super key. And coming to the E attribute, so by using the E, so we can get a E. And if you know E, we can get a C. That's it. Only 2 attributes. So this is also not a super key. Next, H. So there is no functional dependency with the attribute H. So only H can be determined. So this is also not a super key. Now, the super key. What are the super keys from this one, right? So the super keys are A, B, C, D, E, and H. Okay. Next, A, C, D, E, and H. Next, A, D, E, and H. Next, D, E, and H. So these are the super keys. These are the super keys. So from this, the candidate key is D, E, H, because this is a minimal set. Okay, among that one, this is the minimal set because this is having only 3 attributes, this one 4 attributes, this one 5 attributes, and this one 6 attributes. So the minimal set of super key is DEH. So DEH. So whether we can decide that DEH is the only candidate key for this given relation? No. So we have to find out the prime attributes. So what are the prime attributes? So these prime attributes are the attributes which are involved in the candidate key. So prime attributes are D, E, and H. What we have to do? We have to check whether any one of the prime attribute resides on RHS of any one of the functional dependency. So you can see DEH. So this one. So BC tends to D is having RHS, okay, prime attribute as RHS. So prime attribute as RHS. So what we have to do? We have to replace. So what we have to do? Replace, okay, so prime attribute with LHS, right? So what is the candidate key? DEH. So we need to replace this D. With the corresponding LHS. LHS means this one. So this one becomes BCEH. We are replacing D with corresponding LHS. So BCEH. Just find out the closure for this one. So we can determine B, we can determine C, we can determine E, we can determine H, and if you know BC, we can determine D, and if you know D, we can determine A. So is it everything fine? A, B, C, D, E, H, right? So this is also a super key. Right? So we can add here. So B, C, E, and H. What happens? Again, reduce this one. So we have to repeat the same process. So reduce this one. So from here, anything we can reduce. So if you know E, we can remove C. If you know E, we can determine C. So C can be removed. So simply we can use B, E, and H. So find out the closure for this one, and this is a super key. Okay, this one is a super key. B, E, H. So go with a B, E, and H. And if you know E, we can get a C. So now the resultant set we are having B and C. With the help of BC, we can get a D. And if you know D, we can get A. So A. So this is also a super key. So BEH is also a super key. Again, is there any chance of reducing further of this particular BEH? No. Now again, find out the combinations. BE. So write down this one, BE. So we can determine B, comma E, and if you know E, we can get a C. If you know BC, we can get a D. If you know D, we can get A. Right? What about H? There is no H. So simply we can say this is not a super key. And next one, E and H. So find out the closure of E and H. E and H. And now if you know E, we can get a C. And any other attribute we can determine? No. So this is also not a super key. Next, BH. B and H. So determine B and H, and if you know B and H, no other attribute can be determined. So this is also not a super key. Now find out the closures for single attribute. So B, find out the attribute of B. So we can find B, and if you know B, so no other attribute can be determined. So this is also not a super key. Next, E, we can determine E, and if you know E, we can get C. Only two attributes can be determined by using E. So that is also not a super key. And H, so there is no functional dependency of H. So only H can be determined by using H. So this is also not a super key. Now, what are the super keys now? This one. So already we have seen the DEH is a candidate key, and we have repeated the procedure. Now what is the another candidate key? So this is also a candidate key, because BEH is also a super key, and it is also a minimal set of super key, because here we are having 3 attributes and here also we are having 3 attributes. So the second one is BEH. So shall we conclude that there are 2 candidate keys? No. So again we have to repeat the same process. Again we have to find out the prime attributes, and again you have to repeat the same process. So I'll erase this one. I will write this one. So here I'll write this is a super key and this is also a super key. Now, so here the prime attributes. What are the prime attributes? B, E, and H. B, E and H. Now what we have to do? So we have to check whether any one of the prime attributes are in the RHS of any one of the functional dependency. So B, E, H. So you can observe here the first functional dependency. Yes. So A tends to B. So here the prime attribute as RHS. So what we have to do? Replace prime attribute with LHS. So we need to replace prime attribute with LHS. So what is the prime candidate key? So BEH becomes prime attribute AEH. So we have replaced B with corresponding LHS. So now again find out AEH closure. AEH closure. So from AEH we can find A, E and H. So if you know A, we can get a B. So we can get a B here. If you know B, if you know E, we can get a C. If you know BC, we can get a D. So you can observe all the 6 attributes have been determined by using AEH. So this is a super key. So we can add here, that is a E and H, right? So any other chances to reduce this candidate key by using any functional dependency? If you know E, we can determine C, but C is not here. If you know A, we can determine B, but B is not here. So there is no functional dependency of on H attributes, right? Now just repeat the process by writing all the possibilities, all the combinations. So find out the AE closure. So by using AE, we can determine A comma E, and if you know A, we can determine B, and if you know E, we can determine C, and if you know BC, we can determine D. What about H? So there is no possibility. So this is not a super key. This is not a super key. Then E and H. E and H. So we can determine E value and H attribute. E attribute and H attribute. And if you know E, we can determine C. So directly we can determine C. So any other attribute we can determine? No. So this is also not a super key. Next, AH. AH. So we can determine A and H. And if you know A, we can determine B. So no other attribute can be determined by using the given functional dependencies. So this is also not a super key. And find out the single attribute closures. A plus. So coming to the A plus, we can determine A, and if you know A, we can determine B. Only 2 attributes we can determine, but this is also not a super key. Next, E closure. So by using E closure, we can determine E and only C. So here we have done E and C. So this is also not a super key. And H closure also we can determine only H. Other than H, no other attribute can be determined. So this is also not a super key. So we can simply say AEH is also a candidate key. AEH is also a candidate key. Right? So now you can observe. So shall we decide that only the candidate keys are DEH, BEH and AEH? No. Again we have to find out the prime attributes. So what are the prime attributes here? So prime attributes are A, comma E, comma H. So check whether any one of the prime attribute is on the RHS of any functional dependency. Yes, here it is. So B tends to A. So here it is a prime attribute as RHS. So what we have to do? Replace prime attribute with corresponding LHS. So AEH becomes LHS is D. So DEH. And shall we repeat the same process? It's not required because DEH is already a candidate key. DEH is already a candidate key. So we need not repeat the process. We can stop here. So the super keys for this particular relation are this one. So 1, 2, 3, 4, 5, 6, 7 super keys. And among that one, the minimal set of super keys is a candidate key. So the minimal set of super keys are DEH, BEH and AEH. So these are the candidate keys of a given relation. So first we need to find out the one candidate key and then we have to find out the prime attributes, and we have to check whether the prime attributes are resides on the RHS of any one of the functional dependency. If so, replace the prime attribute place with a corresponding LHS, and again repeat the same process, right? So until you got the repeated candidate key. So here we got DEH, which is already a candidate key, so we can stop the procedure here. So this is how we can find the super keys and the candidate keys by using the functional dependencies and the attribute closure, right? So hope you understood this procedure. So if you are having any doubts regarding this procedure, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.